Alright, we're ready to move on to number 11. Alright, these triangles should look familiar. These are the same triangles we used above. The triangles below are similar. Again, they're telling us that they're similar, so we already know some things right off the bat. Alright, it says using the side lengths of triangle DEF, so they gave us all the side lengths, and the fact that they're similar. That means that there's corresponding sides here. What are the lengths of sides AC and AB? Alright, so AC, we could always go back to that first page. We saw that it corresponds to EF, and BC corresponds to DF, and AB corresponds to ED. Well, just looking at AC, we don't really know anything, so we got to figure out something here. If DF corresponds to BC, this is 3 and that's 12. How did we get from 3 to 12? What did we do? We multiplied by 4 to get from here to here. Now if I went from this way to that way, it would be divided by 4. But since we know all of this and we're trying to figure these out, I want to go from here to here. So we're going from the small shape to the bigger shape. So 3 times 4 is 12. Since they're similar, you know that every other side is going to be the same way. So to get AC, since EF matches up with it or corresponds, 5 times 4 is the answer to AC, and 5 times 4 is 20. Alright, so we have our answer down here of 20. Now they want AB. Same rule, 4 times 4, since they're similar, is going to be the answer for AB. So 4 times 4 is 16, so we have our answer 16 right here. Alright, so B says, what is the scale factor from triangle DEF to triangle ABC? So we want to go from here to here. So whatever we're multiplying by, the height and the width by, that's going to be our scale factor. So our scale factor is 4. Alright, now the next one asks, what is the scale factor from triangle ABC to DEF? So now we're going from big to small. The only way you could create a small figure from a big figure is to multiply all the dimensions by a fraction or decimal. So if small to big is 4, big to small would be the reciprocal. So that would be 1/4. Alright, our next question says, how many times greater is the perimeter of triangle ABC, that it should be than the perimeter of triangle DEF? How many times greater is ABC than DEF? When you're dealing with perimeter, it's always going to be what the scale factor is. So this is a quick, easy answer. This is going to be 4 times greater than that. The perimeter is 4 times greater. How many copies, now we're dealing with area, how many copies of triangle DEF, which is this one, will it take to cover triangle ABC with no overlaps or gaps? Alright, how are we going to figure that one out? Alright, when we're dealing with copies or area, it's the scale factor squared. So the scale factor from here to here was 4. So the number of copies that'll fit in there would be 4 times 4 is 16. So that's our answer for that. I could write out 4 times 4 here, but you know the scale factor is 4, so 4 times 4 is 16.